name is Lindmark. I'm the CEO of Data Access Sweden. I'm very proud to be here, and I'm going to present Data Access as a company, what we do, and a little bit about our partners. Listen to these presentations yesterday and today. I think our headline is very much in common here. So we are more looking at taking care of the data, and big data and how we work with that is more an issue than just the hardware. So I want to touch to data access and our focus areas, our way, how we are working with our team and partners. I'm going to touch to something called Geneva. Maybe you don't know what it is, but I will tell you a little bit about it. A case study and a summary around that. So if you start up with something called about the goal for us in data access. Today it's harder than ever before to be to keep up with the changing society, and every day new trend is born, and especially when it comes to IT companies and IT systems. So we would like to help our customer to reach the top of the mountain, to be able to do what they would like to do with an environment. We are an IT consultant company, and we focus on HPC. So we have 4 different areas. We are doing HPC, the traditional HPC. We do big data, computer solutions, and consulting. Normally, we have been working with HPC for a very long time, and we have been in the vendor side. We've seen most of the systems that way. So HPC is our focus and main business. We have customers like the universities, and we deliver big systems in that area. We focus on HPC as not just the hardware and the services around that. We have a history and experience around that. We have been in this area for like 30 years. We are a handful of people working with data access. We do mostly HPC for research and development, and that's university, on the other hand, and it's the industry on the other hand. There's another thing that's driving. We are talking about what is driving HPC, and we came up with this, the handheld devices, and internet is driving HPC, and also big data. A lot of talking around big data. Just to give a clue what driving it's like, if you work on your iPhone or your smart device, and just make a click on Facebook, you generate up to 1 megabyte of memory directly. So this talk about HPC and the big data is generating a lot of data. So the definition, we have been listening to a presentation yesterday and today about big data, the long tail and other things around what big data is. And I think if we go back to some of the presentations, the memory and the data will be the assets. From there we will do the calculations, we'll find out what happened. So big data and HPC, like taking the data, do analysis of it, and handle it that way, will be very much interesting. So there's a lot of products that's similar to this, working with it, and you all know about Hadoop, NoSQL, and MongoDB. We have we were discussing around consultancy and programming. So we do consultancy around system solutions. We work with storage and software and also networking. Okay. Yes, exactly. Going to the picture. Software specialist development and programmers. What we're talking about is parallel programming. I think we believe that a lot of the skills that is needed is in the parallel programming area, and we provide consultants that way. So what we do, we work with fewer customers. We try to engage us very much in the products, and we love to do that. We see two focus areas, and that is university and what we learn from the university when it's tough to get to the university in sense of requirements, and so we learn from that and we do that job for industry as well. We look more not for one special product, we look more to what is the need from the customer and how shall we treat that need. So we have a lot of partners that help us take that way. So the team we are a handful of people. We have an office in Sweden and in Norway. We're looking forward to expand, maybe coming to this area as well. We work with sales team, product leaders, to work on different kind of RFQs. We don't go into everything. We like to focus on what we can really win and do good for the customer. So we would like to be in the process very from the beginning and work with that. So that is our long experience. We work in that way. We have several partners, and the partners we have is not chosen that we say this company is good and that one is not good. We are looking at what is the best technology for the moment. And always when the university goes out and look for new systems, they are on the edge of the technology, and we would like to see, well, be on the edge, but we had to deliver what the customer want to have. So we have heard about the machine future product, fantastic. We can build a machine today with other kind of solutions, from high-speed networking to ultra-high speed memory. Universities are good on this. The knowledge is there, and we help the university to provide them with the latest technology. For that we use special resources, and the special resources can be consultant in an area where we have like networking or high-speed connections in some way, or programming. IT infrastructure consultants, of course, and as we come to this parallel programming skills, we think it's not just a machine, it's not what we put together, it's also very much how you treat the systems and how you really optimize them. And an optimized system can achieve a lot more than just one box. So here's some of our partners, and the list can be longer than this. And why have we chosen these partners? We believe that we are a small company with big resources. These kind of partners, they have products, they have ability to help us deliver the maximum in each RFQ. As you can see, we are working with one of the biggest player in the performance area on network in Mellanox. And if you don't know about that, it's a company with performance better than anyone else. And we are just in the delivering phase for switches around Mellanox to university. And there's the same, on other universities looking for the latest technology that is available today. And that is. And NVIDIA is another where you use GPUs very heavily, graphic processor units, and that is a performance pusher. So we saw that in a presentation later, where you can have a lot of cores, and you can push up. Well, we're talking just about the performance, the teraflop performance, but there's other things around it as well. The memory size or the storage or other things around. So there's a big player, and with this kind of partners, we can deliver to, well, whatever customer and size of system there are. There is I can talk long time about these partners, but I would like to touch on Geneva. How many knows about Geneva here? 1, 2, 3. My partner, okay. And so Geneva. If you have the best product in the world, you have to communicate it to others that is the best product. Many of the technical companies, and we have seen this kind of technical companies in mass during the years, and they come up with the best technology and they disappear. And but this one is not that. They're just quiet. Nobody knows it. But if I say Sun Grid Engine, then maybe people know what it is. Sun Grid Engine, you know that? Okay, so but this is with this product, you can build a virtual supercomputer. You can take care of all your resources, and you can run job. If you're just low latency job where you had to have most performance on a box or in a cluster, then you maybe use Slurm as a common product in the university. 80% of all university use that product. But if you have other kind of simulations, if there is big data simulations or smaller jobs, a combination between smaller jobs, bigger jobs, and so on, then this product can build a virtual cluster over a company, over a country, over geographies, and balance the load on everything from PCs to dedicated servers to cluster. When Oracle bought Sun, this product came with them. And they said open source is very good, very good. But some years later they said, okay, drop it. So the people at the project, Sun Grid, and they said, okay, we buy it out. So they took it out and formed this company. It was 2011. They got all the source code and everything. And they also have an open source community for Sun Grid Engine. So they opened it up, and now there's a very strong demand on this kind of product. These are some of the challenges we have been talking about. Nodes and sockets, they count as they are, but the cores are exploding. We have seen in the presentation from Intel that we go from 8, 10, 16. Even in the future, they're talking about 60 cores per CPU. And the cores, okay, how should you use them? How can you handle them? That's a problem. With a core explosion, the number of jobs also explodes. And you need a product that can handle that. Shorter job run times. I heard in a presentation yesterday about the long tail and small jobs and big jobs, the discussion around that. Larger commercial sites exceed more than 100,000 cores, and that is normal today. Okay, there's a lot of other things. We don't have as much money as we want. We had to get most out of the environment we have. We have maybe products that is not on the latest stage. We have them. They do something else on them. So many of them are idle, and we lose CPU cycles. And we have requirement for different kind of job, throughput, array job, large parallel, and so on. And you would like to have this automated, not go to a certain place and start a job. You would like to do it automatically. You would like to reserve job and also be able to pay for what you're using. So the products that you're talking about is Geneva Grid Engine, and that is a resource optimization product. You can optimize your resources. License is one of them. In research, you pay a lot of money for licensing, and by this you can share and use the license when it's needed. The other way, you can go to the cloud. You connect it to like Hadoop or Amazon, and that way, and you can handle the load between your cluster and external resources. And of course, Unisite comes with it. It's very, very important to understand what we are doing with the data, because the data is the most important thing we have. So all reports in real time and analytics is brought into it as well. So the technology behind this, there are like 3-4 commercial sites, commercial companies in this area. In the open source, it's maybe 10 or 20 that is used very much. This company has 20 years of proven technology behind it, and we have seen it when it started up at that time. You can larger cluster capacity, more than 150,000 cores in one system. Larger job, more than 5 million jobs per day, and the fast submission up to 1,200 jobs per second. And that is handled through this software, so you can spread your load between, as I say, everyone that's in this cluster, this virtual cluster. So workload optimization, to just take it easy, what it does here is to optimize the traffic between network, memory, data, and CPU. So that is what workload optimization product does. So when I sold the first one, we had another product. I sold it as an optimization product for a supercomputer, and then we saw, okay, this could maybe be something else. So we saw there was 200 machines in other companies. Said, okay, we are doing calculations, and we installed the product at compilation. They were doing compilation, and we installed this one and said, okay, build a cluster of it, and these 200 machines went down a factor of 10 in compilation time, just to optimize the traffic between the different machines. So it's used in life science, electric design, whatever, oil and gas exploration. There is one of the biggest installation with 200,000 cores in one cluster. Manufacturing, it's used to when you do crash analysis or whatever you do, fluid dynamics and so, and scientific research. Financial services another, where you have you do the calculations. That is long time calculations, and it can take hours or maybe 10 hours to calculate all the financial instruments. By using this, you could use, like in one case, 3,000 CPUs that is calculating the risk for the investment. And then the time goes down to minutes instead of having hours, and then you couldn't do any business. The other way of what you're doing here is also use it to build private clouds, hybrid clouds, and public clouds. This had been called grid computing before, but now everything is in the cloud, so it's another wording. but you can build it that way. Here's some of the customer and the use cases. I take just one of them, and that is Jeppesen. You maybe not know what Jeppesen is. Jeppesen is a company, a Danish company from the beginning that bought a company called Karman from Gothenburg. And what they are doing, they recalculate all the personnel and resources for the air companies. And they have like 50 customers. So whatever happened, is it a strike or something happened, and all the aircraft on the ground, and they had to recalculate everything with personnel, with flights and everything. It's done by the Jeppesen's product, and the engine in it is the Univa grid engine. I think I'm not going into more of these, but they're used in, as you see, in all different sectors. The only sector that is not so much to use this in the university, as this is a product that costs money. So, Univa, as I say, it's a commercial company. It's like a Red Hat for Linux. This is the commercial product for load balancing and optimization. So they have the scalability, they have the normal updates and also support. So these 4 products, you can download it for free and test it. And as I say, the engine in this is the grid engine that handles the traffic in the cluster. So what we are, anyhow, we are focusing on HPC, big data, computer solutions, and skilled consultants that we are working with. As we say, we are not the traditional way. We look at what kind of vendor shall we use. We are specialists from IT, within IT, and we do the customization of product. We have a strong focus in the university, as there is a high demand of products, but also of competence. Then we are the team, a handful of people that we work in data access. Univa, heard about that? It's a workload optimization solution where we can build virtual clusters and save money, be more effective, and combine it with the supercomputers. And we think in all different ways, supercomputers is the future. And if you build it as one single system, or if you have many different kind of systems, you have to get the power to develop or do the calculations, and you can do it otherwise in systems or by using this kind of software that we're talking about. So that was all for me.
Thank you very much.
Thank you.